airline. So have airports around the world.
Keep on dreaming.
Dream big. You buy my tickets. Very expensive to go to UK.
If you manage to get an airline, I'm wanting free flights. I want to roll up in the airport and say, it's alright, I know KJ. Give me first class ASAP. Tell him his maths and physics teacher is here. Okay, right, let me just save the video from what we just did. Yeah. So we just did maths for engineering lesson, functions and mappings, transformations, NCUK. Alright. So next now, the modulus function.
Modulus.
Also called, if you're an American, the absolute function.
It's one that just makes minus plus.
Yep. Yeah, so it seems simple, but actually it can be a little bit difficult. The modulus function. You think that, wouldn't you? You'd be surprised. Right. So, I think you all know the modulus function, but anyways, to be completely clear, if the number is positive, then the modulus or the absolute value of it remains positive, so
yes.
Absolutely no change. And if it is negative, then you flip the sign. So for example, this is a 4, this is a 5, this is a 4. In other words, the sign is gone. It always becomes positive. So it seems like a simple function. Very simple. Okay, can we go down?
Yeah.
Oh, it's fun.
Yeah. So, for example, the graph of it. Does anyone know what the graph of the modulus function looks like?
It's always a positive.
Yeah, it's always a positive. What's the graph? No? So if x is 1, what's y?
1.
Oh, hang on. If x is 0, what's y?
0.
If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3, and so on. Straight line. If x is minus 1, what's y?
1.
If x is minus 2, what's y?
1. 2.
If x is minus 3, what's y? 3. So the graph is a V-shaped graph. Please note that. The modulus function makes a V-shaped graph.
Is x squared.
It is like x squared, but it's linear on both sides, not curved.
Y is equal to
So is that
x
absolute value of x squared?
Yes, this we'll all get to in a moment, in time. Patience, young one, patience. Okay, you got this? You got this? Right, so let's say, can I go down?
Yep.
Let's say I want to graph something like this. Y equals 2 absolute 3x minus 6 plus 1. Chillax. Who's calling you?
my brother.
No way are you answering that now.
It's an emergency. Cat's just died.
It's not an emergency.
Asking what's up.
No. Now, we're ready to graph this.
Yeah.
So what we do first is we rewrite this as y equals 2 absolute 3 bracket x minus 2 bracket absolute plus 1. So what I've done is, you see this 3 here? I've taken it out. I just took the 3 out. So it's 3 bracket x minus 2 instead of 3x minus 6. And the reason for doing that is because now it's like a transformation problem. Imagine you have this function and I transform this function. where this is the A, this is the B, this is the C, and this is the D. It's a transformation problem now. So what type of graph is absolute of x? It's this V shape. Now let's transform it. So the 2, what will the 2 do? Stretch it,
Yeah.
like this. The 3 here,
Wait, stretch it. Why didn't you go down?
it'll stretch it, so it'll like this.
Okay.
The graph
Yeah?
originally was.
The red,
The y equals x.
y equals modulus x, and I'm transforming it.
Okay.
So this is really what I want to draw from this graph.
Mm-hmm.
So the 2 here stretches it up.
Okay.
The 3 compresses it. So right now it's very skinny looking.
Mm-hmm.
The minus 2 moves this to the right.
Oh yeah.
So it'll be skinny and over here 2 units to the right.
Mm-hmm.
And then the plus 1
Move it up.
moves it up. So the graph will finish over here, and you can exactly know where this point is. What will it be? The point 2,
And
1, because this got moved over and got moved up. So we'll graph that now to see.
And you have to write the information at the steps of transformation?
Not unless they ask you to.
Okay.
Okay, can we have a look at the graph in the program? Oh, I need to open it. Yeah, no, take your time. Yeah? We see that? Yeah. So there's 2 ways you can graph this. The first way you can graph it is by using the transformation method, by using the rules of transformations that you learned in the last lesson. Focus, please, focus. So the first way is the transformation method. The second way I'll show you in a moment. Let me just open up the graphing program here.
Do we have in this like a reflection or something?
Yeah.
In the book.
In this,
Yeah. Like there is transformation.
some of these have minus in them, yeah. Right. So let me first start by drawing. Come on. Come on. There we go. Let me first start by drawing plain old absolute of x. Yeah, better than 5. Okay. So we know what shape this is. It is a V shape. Bam. Right. What is the function I asked you to draw? 2 absolute of
3x
yeah.
minus 6
Yeah.
plus 1.
Like that.
Yes.
So I am expecting this graph to be to the right, up, still skinnier, and the minimum is at 2, 1. Let's see what we get. So I'm expecting the bottom to be here. Yeah? Bam. Yeah. So that is how we do it. But I said there are 2 ways to do this graphing problem, so I'll show you the second way now. Can I scroll down? Yeah.
That should be the easy one then.
This is the easier way, but the other way is an important way, and it's useful for some of the other more difficult problems. So suppose I ask you to draw this now. Well, before I ask you to draw that, I ask you to solve this equation. Right, so before I can show you the second method for graphing, I first have to show you how to solve an equation that has the absolute function in it. Some people might actually know already how to solve this. So the first thing you can see is, well, at least we can divide both sides by minus 4 even. So I have absolute of x minus 3 equals 4. Now, by the way, explain to me why this has no solutions. What I just wrote. If I did this, now it is unsolvable. Why is that? Yeah? Yeah, absolute must be positive. So what value of x can you pick to make the absolute of x minus 3 negative?
Nothing.
Nothing at all.
Why?
Yeah. Anyways, fortunately, it is solvable. Does anybody know what to do to solve this?
Square.
Yes, there's two ways to do it. So the first method, you can square it. Let's explain why that method works. Do you know why it works?
Because the square will also remove the negative.
Yeah, basically. Right, so I'll just go to the side here. Minus 2 squared, that equals 4. Minus 2 squared absolute equals 4. Minus 2 absolute squared equals 4. So notice that if you don't have the absolute, if you have the absolute on the outside of the square, or if you have the absolute on the inside of the square, the answer's always the same. So basically, if you ever have an absolute and a square together, and it doesn't matter which way around it is, you can always drop the absolute. The answer is still the same. Because like you said, squaring makes it positive anyways. So squaring is one technique to get rid of the absolute. So here, if I square both sides, absolute of x minus 3 squared equals 4 squared. Now what did I say? We can always drop the absolute when we square. So this becomes brackets x minus 3 squared equals 16. X squared minus 6x plus 9 equals 16. X squared minus 6x minus 25 equals 0. Yeah. This has two roots. What is it going to be? 5 and 5. What is it? No, actually, that's not 25. Sorry, go back in time. 16 minus 9 is 7. Minus 7 equals 0. So this has two roots. X equals 7 or minus 1. So you have two answers here. Say again.
What about the second?
Second method now.
X equals minus 1 or
7.
also if you just when you squared it and
Mhm.
now square rooted it again, that'll be x minus 3
Equals.
equals plus or minus.
Correct, which is kind of like the second method, which we'll do now. Second method, yep.
Yeah, this.
Hey, yeah, come on. Right, so the second method, you have the absolute of x minus 3 equals 4. But if you really think about it, there are only two ways an absolute of a number could equal 4. If that number is 4, or if it's minus 4. What's the absolute of 4? 4. And of minus 4? Minus 4. 4. So what I'm saying here is, this piece here must be plus or minus 4. It's the only way the absolute of it could be 4. I mean, it can't be 5, because then here would be 5. So you have that x minus 3 must equal plus or minus 4. So then that means x equals 3 plus or minus 4. So that means x equals 7 or minus 1. Yes?
Yeah.
Okay, so we know how to solve modulus equations. Flick back to what I had earlier, which I've now lost. Where to go? Where was it? Did I delete it? I guess so. No, I wanted you to draw a graph, but I'll just write it again. So now I want you to graph this. So the first method I showed you was transformation. The second method is good old-fashioned graphing techniques from semester 1. First you find where it crosses the x-axis, then you find where it crosses the y-axis, and then we'll find the turning point. So, the easy one first, where it crosses the y-axis. How do I find that? Yes, but how do I find it? Yeah, so we let x equal
X minus
0.
0.
Oh, yeah, zero.
Yeah, so it's not actually 16, because if I put x as 0, 0 minus 3 is minus 3, absolute of minus 3 is 3, times 4 is,
Minus 7.
3 times 4 is
Sorry, minus 12.
minus 12, plus 16,
4.
4, so the y is actually 4. So 0, 4 is my first point.
Why did you go x to 0?
I'm deliberately finding where it crosses the y-axis. So I make x equals 0 to find y. Then I find where it crosses the y-axis. What are these points called?
Minimum.
Roots. Thank you. Somebody remembers their vocabulary. So now I say let y equal 0. So now I have minus 4 absolute of x minus 3 plus 16 equals 0.
Right? Minus.
So again, take it to the other side. Does this equation look familiar? It's the one you did 60 seconds ago. You already know what the answer is. What's the answer here?
7 or minus
7
Or minus 1.
or minus 1.
Which is that equals to the minus the 1,
Divide minus 16 by minus 4 and you get 4, which is exactly what you did 60 seconds ago. Same thing. Right, so what are the y's here? 0 and 0. So far so good. We have 1, 2, 3 points.
Minus 1, 0, 1.
Yeah. Finally, I want to get the turning point. Now, any ideas on how I can get the turning point? So actually, first question, will this be a V shape or will it be a mountain shape? Mountain shape, very good. So the turning point is a maximum. So how or what or how can I find the maximum here? Because have I taught you the derivative of the absolute? No.
Yes.
I have not. Be great if I did. But I didn't. So any other ideas? I'll give you a tiny hint. If you rewrite this as 16 minus 4 absolute x minus 3, the maximum.
I don't see the difference.
Maximum would be around 60.
Let me ask you this. If I make the x bigger, what happens to x minus 3? It gets bigger. What happens to the absolute of x minus 3? It gets bigger. If I multiply this by 4, it gets bigger. Minus 4 times all of this is getting bigger. So as x gets bigger, what happens to this piece at the end? It gets bigger. So if I have 16 minus a bigger and bigger number, the answer is getting smaller. If I want the maximum, what's the maximum 16 can be? 16. What is the maximum minus 4 absolute x minus 3 can be? What's the maximum this can be?
16.
No?
4.
No? 0. Why? Because I know you just got lucky there. Absolute. Positive or negative? Multiplied by minus 4? Positive or negative? Negative. What's the biggest a negative number can be?
Infinity.
No, that's the smallest.
Oh,
Minus one.
minus one.
No,
Minus infinity.
no,
Smallest
that's
one?
it's zero.
Zero.
Why zero?
Well, I mean, which is bigger, -1 or -2?
Minus one.
Yeah. Which is bigger, -1, -2, -3? Which is biggest? -1. Can it ever be positive? No, this can never be positive because this piece is positive and this piece here is negative. When you multiply them together, the result is
Negative.
negative. So what's the biggest a negative number can be? It's zero. Can it ever be positive? No. When will this be zero? When the x is
Minus plus
3. So when the x is 3, the y will be 16. Now, before you freak out on me, cast your mind back to completing the square. This piece is always positive. This piece is b. What's the turning point here? A, b. Because you make this piece 0, and this is the y. Now, draw a comparison. If I say y equals the absolute of x minus a plus b, notice the similarities. This is always positive. The smallest this could be is 0. This happens when x equals a, and the b is what you get for the y. For this graph, which will be a V shape at AB. So the comparison between this and completing the square is really, it's identical. So if I go back here, if I make this 0, what do I get for x? X must be 3. And then what would the y value be when x is 3? 16. And this is the point which is the maximum at the top of the mountain. So the peak is at 316. Mm-hmm. Is that enough? Can you see there? So if I do a very, very ugly sketch here, look, -1, 7 are the roots, agreed? Where does it cross the y-axis? What's it? 4. And then what is the peak point at? Here is 316. Yeah? Now the graph is actually quite useful for some of these problems. But before we continue with this, let me draw the nice graph for you. Can you read the function back to me? It is 16
-4 absolute.
Yep.
That's -3.
Alright, so let's graph this. Calm yourself down there, KJ. Thank you. Where's zoom out? Sorry. Right, where did I say it crosses the... hang on, let me center on... Right, where did I say it crosses the x-axis? What were the roots we calculated? -1 and 7. Seems right? What did I say it crosses the y-axis at? 4. And the maximum was 316. Yeah. Now, why would you care about the graph? Well, you would care about the graph because, for example, if I asked you to do something like this, what was it, -16, what was it, -16?
16 minus 4.
Thank you, somebody's awake. 16 minus 4,
Modulus.
yes?
X minus 3.
Now, if I asked you to solve this, with the graph, this is easy to do. Because if you look at the graph, if I call this here y, is 16 minus 4 modulus x minus 3. On the graph, where is this less than 0?
The minus 1.
x less than or equal to minus 1 or x greater than or equal to 7. So if I ask you to do a problem like this, one way you could do it is by looking at the graph. But that's only one way to do it. Another way you could do it, you try to solve this. Yes? You divide by minus 4. What happens when you divide by minus 4? This gets flipped. And then you square both sides. So you get x squared minus 6x plus 9 must be bigger than or equal to 16. Is this type of problem looking familiar? You've done this in semester 1. What are the two roots here of this quadratic? Minus 1 and 7. When is this quadratic when is this quadratic greater than 0?
When it's less than 1.
When it's less than 1 or
Greater than 7.
same answer. Not only that, there is another way you can do it. You have many ways to do these problems. So the other way to do it, let me show you. You know what, funny enough, no actually, not this time.
What square is this one?
No, he said completing the square.
Oh.
Yeah. Sorry, let me go back to this over here. 16 minus 4 absolute x minus 3 less than or equal to 0. Not substitution quite. Anyone got an idea?
Solving with the
You use them,
Huh? The what method?
Steven, I cannot work it out with the first, with the two methods that you gave.
You could square it. Yeah, and I'm showing you a second method now.
third method.
Oh yeah, sorry, there's a graph. So yeah, you could square it, which we just did a moment ago.
This easy way that you gave.
Yes, that's what I'm showing you now. It's something like the easy way. You see, the easy way only worked when it was equal.
So if it is
What I'm about to show you. Yeah, if it's less than, let me show you. So what you do is you break this problem up into two halves. Yes?
Yeah, like that.
Yeah. So the first part is if x minus 3 is a positive. And the second part is if x minus 3 is a negative. So if x minus 3 is positive, then do we need the absolute sign anymore? No, it's not necessary. It's positive already. Yes? So we have 16 minus 4 x minus 3 less than 0. This you've done. Easy peasy. 16 minus 4x plus 12 less than or equal to 0. 28 less than or equal to 4x. 7. X must be bigger than 7. Hey, that sounds familiar. But hang on, you must be very careful. Very, very careful. Because for this question we said x minus 3 must be positive. So this answer is not finished. You must say and x must be bigger than 3. Because I said this at the beginning. Now you realize you can actually put these two together to get one answer at the end. If I said x is bigger than 7 and x must be bigger than 3, I need a number which is bigger than 3 and bigger than 7. I can say that simply as x must be bigger than 7. I mean, if I said x must be bigger than 3 and it must be bigger than 7, therefore it must be bigger than 7. It can't be between 3 and 7. It can't be less than 3. It must be bigger than 7.
What is the second part?
Now the second part is if x minus 3 is negative. So if it's negative, what does the absolute do here? What does it do? It flips the sign.
Yep.
So now this becomes minus x plus 3 less than or equal to 0. So I have 16 plus 4x minus 12 less than or equal to 0. I have 4x is less than, let's see, that's 4, less than or equal to minus 4. Sorry, did I do something wrong there? 4x4. That's right, isn't it?
What's
Mhm.
that 4x something?
That's 4x less than or equal to minus 4.
Yes.
Oh, okay.
No, something went wrong here. Hang on.
Looks correct.
Is it?
Yes.
Plus,
Practical.
minus, 16 minus 12 is 4 to the right. So that x must be bigger than or equal to
1
minus 1. But don't forget, we still need this, where x must be less than, can I wait till the end, please?
Yeah.
Yes. X must be less than minus 3. So my answer here is x is bigger than minus 1 and x must be smaller than minus 3. I feel like something screwy happened here. Yes?
Yes, you don't meant to change.
You don't have to change because
Because you
it's
do
positive,
divide
it's
by
not minus.
minus.
You flip the sign, the greater.
Yes.
You change it, taking plus.
Oh, thanks. Thank goodness for that. I was worried that the answer got screwed up. Right. So, yeah, why did I flip it? Because I'm dividing by 4,
Yeah.
not minus 4.
Yeah.
I'm hungry. So x must be less than minus 1. And here x must be less than minus 3. So your answer is x must be less than minus 1 and x must be less than minus 3. So together,
X must be less than minus 1. Less than, okay. And x minus 3. You can say it's less than minus 1 only.
can I?
Yeah, because
Are you sure?
it's even between, you know. So 1 is greater.
So I want x to be smaller than minus 1 and to be smaller than minus 3.
You can say it's less. No, you cannot.
Yes.
It's less, it should be minus 3.
This one here, x should be less than minus
Minus
3. Is that different to what I got earlier?
Yeah.
It is different. So hang on, something went wrong here. Unless I wrote the question down wrong. 16 minus 4x, x minus 3. Okay. Ah, no. Sorry. We need to be careful here. Please look. This and this, we're treating it like it's the same. So, how do I even care about this? Tell me. Please tell me. Now, your best choice might be to say, no, I don't care, and I'm sorry. Or you could try and explain why I care. What will you choose to do?
No, I'm sorry.
Good choice.
Because I want to continue.
Yes. These two here aren't of the same importance. In fact, because the question started with x minus 3 is less than 0, from the beginning of the question we already know x is less than minus 3. So in your head, you need to think about this as having top priority and this as having the next priority.
Why?
So because the question began with this. So from the beginning we know that x is less than minus 3. So from the beginning we know that x is less than minus 3 and we require x to be less than minus 1.
Yes, so we have to
Yes.
take x and less than minus.
So which is it now?
That's
We have to make
minus
the
one.
new, you know, the 3 thing.
Huh? Which is it then here?
You can make, you know, x less than minus 1 x as a big.
Dudes! Nobody's noticed my mistake. My goodness.
What?
X minus 3 is less than 0, therefore x is less than...
G.
I have minus 3 here.
Yeah.
X minus 3 is less than 0, so x should be less than
3.
3. So this here is 3. Yes?
So we can say it's x less than minus 1.
So now we can put them together. if x from the beginning is less than 3, and we require x to be less than minus 1, therefore, x is less than minus 1.
No, it's fine.
Now it's right, yeah. Because of the sign mistake here that nobody noticed, x minus 3 is less than 0, that means x is less than 3, not minus 3. Yeah?
Yeah, and you started to explain the new theory.
No, not the new theory. Because as I was going through, I was realising something's not right.
Okay, what's the final answer you want to see?
Yeah, so the final answer is this
Okay.
or this, the two answers together.
You know the other ways around is better.
Yeah, students in the exam, students never do it this way, and most students love doing it this way with the squaring.
Oh, yeah, that's easy.
Yeah, and people only do it this way if the question makes them draw the graph. Obviously, yeah. So if you had it just like this, you should square both sides.
But you have only this method to do this.
No, you have three methods. Method 1 is with the graph.
But method 1 only if it is equal.
Ah, no. If it was like this, you could make it equal, draw the graph, and then on the graph look for when it's less than 0. So it's a bit like, Karar, if I asked you to draw a quadratic, okay, and then you change it to less than 0, well, you still draw the quadratic normally, but the less than 0 part means you take the piece in between. Yeah, so even without the equal, the graph method still works.
Because I don't want to do a graph.
I know, and that's why I said in the exam, students usually do it the graph way if the question makes them draw a graph.
Okay.
But if they don't ask for a graph, if this question, we do it by squaring. This method, you can only use this method in situations when the question is very difficult, which doesn't happen in the exam. But I don't want you thinking that you can forget about this method, because this method here only works for certain difficult problems. Okay, just now, one last thing to look at. Sometimes you can get absolute of a function. Like if I said absolute of, let's say, yeah, like x squared minus 2x minus 3, absolute. And I ask you to draw this. How do you think you might draw this? So let's say I have absolute of, actually let's say minus 3x. Minus 3x plus, no, that's easy, too easy. Minus plus minus. Minus x squared plus 3x minus 2. Okay, I ask you to draw the absolute of this. Any ideas on how I could draw this?
You can replace the whole thing with the
Square it?
yeah.
Not squaring it. Yeah, I mean you could do it like, you know, where does it cross the x-axis, where does it cross the y-axis, and so on. But there is another way you can do it. Any ideas?
Solve it.
Yeah, well, that's what Karar was saying. Like when.
That's easy.
No, it's not. Well, when you say solve it, what's it?
The equation.
Yeah, but what equation?
The inside one.
Yeah, so when you say solve it, what do you mean exactly?
We can make 2 points, you know,
Yeah, and then?
Then we can see with absolute.
Yeah, but those 2 points will be on the x-axis, so the absolute of them won't change, because they'll still, the y value is 0, so the absolute is 0, so that won't change.
To make the equation greater or equals to 0.
No? No. So look, one way you could do this graph is first you just graph this quadratic part.
First way.
So what, the only way, we would graph the quadratic part. Yeah? So what shape is this quadratic? Well, it'll be kind of this hill shape, won't it? Because of the minus x squared. Then, after you graph it, then you absolute it. So what does the absolute value do to a number? It makes it positive. So if no, because if I flip it, then this will go underneath.
But you know from the tip,
Use words.
you can reflect it.
Reflect all of it?
Yeah.
No, because then this will go negative, which is impossible because we know that this should be positive.
No, upside.
The upside?
Yeah. Like this.
No, use your words. Give me words.
You can reflect this
Yeah?
upside.
Reflect this. What's this?
Reflect
And
the
what's
curve.
upside?
Reflect the curve.
Reflect the whole curve.
Yeah.
But then if you reflect the whole curve, you get this, yeah? And that's wrong.
No.
No, you all heard him. He said, reflect. That's what I'm doing.
Not by axis, to reflect it by the y is equal to some with the top.
Over here.
Axis. Horizontal.
Oh, like this?
Yeah.
No, not this either. Not this either. So look, this is equal to y.
Okay.
Now let's look at this here. When the y is positive, the absolute of a positive number is positive. So the graph here is unaffected by the absolute because all the heights are positive anyways.
Yeah.
Only when the graph is negative does the absolute change the value. The absolute of a negative is positive. So for example, when the x is 0, what do I get on the inside? Minus 2, which is down here, isn't it?
Yeah.
But what's the absolute of minus 2? 2. So for this region, and this region only, the graph gets flipped up. So only the negative pieces are reflected upwards. The positive part remains unchanged. Now we're talking, huh?
Just reflect the minus sign.
Yes, that's what I was looking for you to say. Reflect through the x-axis only the negative region of the graph. Right, so let me finish with one weird last example. So suppose I have a graph like this. Y equals, actually let's go all the way back to the graph I did at the start. Where's it gone? Yeah, this one here. So what was the function for this one? Y equals 16 minus 4 absolute x minus 3. I lost you. Here. Steady. Right. So do you remember this graph looked like, let me draw at least a horizontal line. This graph looked like this. Yep. So let's say, what about this graph? Y equals the absolute of 16 minus 4 absolute x minus 3 absolute. Absolute. So what does this graph look like?
I know how to fix that. But we can't use our words to draw it.
Yes, you can.
It makes a W.
It's exactly right. It will make a W shape.
Exactly W.
Exactly W shape. So, just go back to the start of the class when KJ said, Modulus, piece o cake. And I said, well, it can get difficult.
Okay.
Yeah, piece o cake.
Of or okay?
Well, it's of, but a lot of people, for extra emphasis, say o instead of. Piece o cake.
Like fancy,
You know,
just trying to
with the
put
accents,
different
you know,
accents and
like
things.
or so.
No.
Always people don't say oh, say okay.
No, people do say it, but when they want to emphasize it, they don't emphasize cake or piece. They don't say piece of cake, or they don't say piece of cake. They emphasize it by dropping the F.
Yeah.
They drop the F, so piece o cake.
What do you mean emphasize?
If you want to make it stronger, piece of cake.
Okay.
You don't emphasize the piece or the cake. You emphasize it by dropping the F on of.
Okay.
Piece o cake. Yeah? Or you could put a swear at the end. That emphasizes as well. Piece of something bleep bleep cake. Yeah? You learn how to emphasize things in the AP, don't you? Although your teacher probably doesn't teach you to add in swearing to emphasize. You know? Piece of blanking cake. You can imagine the word I deleted. Right? If you don't want to do this, you can emphasize it by dropping the S. Piece o cake. It's much cleaner. Piece of cake. Yeah. Alright. So what you could do here is
Last
no, well,
last one.
do one from each. So like 1A, 2A, 3A, 4A,
Finally.
all of 5 and 6, 7, 8, 9, 10. Really, I'm sorry to tell you this, but you really need to do most of this because number 1 is new. You haven't seen most of this before. And number 2, it's a very common exam question. In fact, the good news is this lesson,
It's not even done.
no, quite the opposite. This lesson and the previous lesson, these 2 lessons together, what you did today, is often one section B question. Which is actually a good thing because how often does 2 pages make one B question? Usually not often. Usually it's a chapter that makes a section B question.
Which one?
Easy.
Literally the 2 lessons today.
No, I'm asking the question number. The last one?
Oh no, like do everything. Except for example in question 1, see number 1, it's enough just to do one of them.
But exercise number 2 is the most important, isn't it?
Today?
Yeah.
Oh no, both for the exam.
I mean like exercise 2 and this topic.
What do you mean exercise 2?
The homework. First and 2 you said 2 is the more common.
What?
You said the whole thing.
No, I said the 2.
Okay.
The 2 lessons today.
No, I'm talking about Modulus Function.
No, I just said it's more difficult than you think. I don't think I said anything about how common it is. I said that the 2 lessons today are usually one section B question on the exam. That's what I said. Right, light on please, and let's get out.